Welcome to IPMWORKS e-learning modules. My name is Nicolas Munier-Jolin. I am from INRAE, France. This video is part of module number 7, which is about assessment of IPM-based systems. This video is about assessment of cost efficiency of low-pesticide IPM-based cropping systems with the case of the DEFI network in France for arable field crops. The DEFI network is a French component of IPMWORKS, the European Farm Demo Network. DEFI was launched in 2010. It is engaging about 2,000 volunteer farmers from different agricultural sectors with the explicit objective of decreasing pesticide use and the explicit approach of redesigning cropping systems, promoting the holistic view of IPM. And the idea is to be site-specific. Each farmer is to find his or her own solutions adapted to the specific context of the farm. The farmers are collecting some information about their practices, which are collected in the agroecosystem database, which can be used for producing some information about cost efficiency of those cropping systems. Martin Lejné made a PhD that was presented in 2017, where he analyzed the data produced by the farms of the DEFI network for the arable field crop sector. And the database he used was composed of 1,000 farms, conventional farms from the arable field sector. And he used the very large range of pesticide use measured by the treatment frequency index, ranging, as you can see on the map on the left side of the slide, from almost 0 for some farms to more than 10 for other farms. And he used this range to address 3 questions. The first question is, what are the technical strategies of those farmers that are using little amount of pesticides? The second question is about cost efficiency of IPM. Is there a connection between low pesticide use and productivity and profitability? And the third question is about a scenario of general adoption of IPM-based systems at the country level. What would be the consequences of such a general adoption of IPM? For the first question about technical strategies of farmers, we use statistical methods to analyze the reason for this range of variation of pesticide use with 2 steps. In the first step, we use regression tree methods to analyze pesticide use as a function of variables describing production situation, variables describing the soil, the climate, the presence or absence of cattle on the farm, the possibility to irrigate the field, or variable describing specific markets regarding, for example, industrial crops in the area of the farm. Based on those variables describing production situation, he found 6 contrasted production situations with contrasted pesticide use. The first 3 production situation in the graph here are production situation with cattle on the farm. When you have mixed farming with cattle, you have an average pesticide use index of 2.4, whereas for the 3 other production situation without cattle, the average TFI is more than 4.1. In the 3 production situations without cattle, 2 of them are based on cereal cropping. And the third one is in the northern part of France, in red, in a region where a lot of industrial crops are grown, such as potato and sugar beet. And then it's in the second step, in each of the 6 production situations, we analyze the range of pesticide use as a function of variables describing the strategies of farmers. And the strategies were described by the crop rotation, tillage, fertilization, cultivars, mechanical weeding, and so on. The whole analysis explains 73% of the variance of pesticide use, which is quite a lot. And the main technical drivers that were identified in the second step of the analysis were the following. First of all, temporary grasslands. The more temporary grasslands in the farms where there is some cattle to be fed by those grasslands, the more temporary grasslands, the less pesticide use. The second factor was crop diversification by including hardy crops or by diversifying sowing periods over the crop rotation. The third factor was the use of resistant cultivars, mainly to diseases. Delaying cereal sowings also tended to decrease pesticide use. Reducing pesticide doses was a factor identified associated to low pesticide use, but also soil tillage, as occasional plowing was frequently associated to farms with low pesticide use, and also moderate fertilization, because high levels of fertilization do increase weed pressure, disease pressure in some crops. So moderating fertilization was identified as a factor to reduce pesticide use. In the second part of the PhD, cost efficiency was addressed. First of all, by analyzing the correlation between pesticide use and productivity at the farming system level. Productivity at the farming system level was assessed through the energy harvested per hectare and per year. And this, the outcome of this analysis was this map with 1,000 dots. Each dot corresponds to a farm site and 3 colors. 3 colors are depending on the correlation between pesticide use, measured by the treatment frequency index, and productivity. There are 3 possibilities. On the red possibility is the positive correlation between TFI and productivity, meaning that those farms that have the highest productivity are also those farms with the highest pesticide use. Meaning in this kind of situation, red ones, there is an antagonism between having a low pesticide use and a high productivity. For the green dots, it is the contrary. The green dots are for negative correlations between pesticide use and productivity, meaning that those farms in those kind of contexts that are using little amount of pesticides tend to have higher productivity. And in the yellow dots, we have a nil slop, meaning that those farms in those kind of production situations that have low pesticide use have the same productivity as compared to the neighbor farms with a higher pesticide use. So both green dots and yellow dots corresponds to situations where we were not able to find any antagonisms between pesticide use and productivity. And you see that the number of red dots on the maps are quite few. We were not able to find an antagonism between pesticide use and productivity for 94% of sites in this network. The only sites where we could find antagonisms were in the northern part of France, where industrial crops such as sugar beet and potato are mostly grown, and those crops are also crops with both a high productivity and a high need for pesticides. He used the same methods to study the correlation between pesticide use and profitability, measured by the net margin expressed in euros per hectare and per year. And this net margin is considering the growth product, but also the input cost and the equipment and machinery cost. And he used the same methods. And still in this method, we found that 78% of sites were either green or yellow, meaning no antagonism between pesticide use and profitability in those kinds of production situations. So clearly, indeed, the conclusion was that IPM and reduction of pesticide use was cost effective in 78% of sites. In the third part of the PhD, Martin studied a scenario of general adoption of IPM-based system at the country level to study the consequences. What would be the consequences if all French farmers would adopt the farming strategy of the DEFI farm from the same context with the lowest pesticide use, but a similar or better profitability? And the first outcome of this scenario was that pesticide use would be reduced by about 40%, meaning that those pioneer farms that are implementing IPM and that are using little amounts of pesticide tend to have 40% less pesticide use than neighbor farmers in the same context. The second aspect considered here is the production volumes at the country level. On the graph here, you have on the left the current production of French agriculture distributed according to different crops that are represented by colors: wheat, barley, maize, oilseed rape, and so on. And on the right side, you have the outcome of the scenario of general adoption of the cropping systems of those DEFI farms with low pesticide use. And you can see that the overall productivity of French agriculture will not be reduced, but would be increased by 6%, with a decrease in the production of cereals, the slight decrease of wheat, a higher, stronger decline of barley production, a slight increase of maize, both silage maize and grain maize, a quite strong decrease of oilseed rape production, and most important, an increase of grain legumes and of temporary grasslands in those farms where there is some livestock to be fed by grassland. And finally, we studied the impacts of this scenario of general adoption of IPM-based systems on the trade balance at the country level. So we identified some negative impacts of the scenario on trade, on the trade balance, due to a decrease in the export of wheat and a stronger decrease in the export of barley, and also in the decrease of the production of energy based on rape, because you know that part of the rape produced in France is used for biofuel and energy production. But those negative impacts due to decrease in exports were compensated for by positive impacts linked due to the increase in maize export, but also to the decrease in energy imports, because those pioneer farmers implementing IPM tend to use less nitrogen fertilizers than neighbor farmers, and this, as you can see, this impacts a lot the needs for imported energy. And most important is the decrease in soybean imports, because those farmers of the DEFI network using little amounts of pesticides tend to produce more local plant proteins from grain legumes and from temporary grasslands, including forage legumes. And you can see that on overall, the trade balance would not be impaired. The trade balance would be improved by 700 million euros, according to this scenario. So the main conclusions of this study is that, first of all, some pioneer farmers in arable field crops are using drastically less pesticides than others in the same production context, and this is possible thanks to holistic IPM and the adoption of measures such as diversified crop rotation, and resistant cultivars and soil tillage and reduced and moderated fertilization. IPM technical solutions are highly site-specific. IPM-based strategies of farmers were very different across regions, soil types, presence or absence of livestock, and so on. But the main conclusion is, in this study, in arable field crops in France at least, IPM was shown to be cost-effective and compatible with good profitability in most farming contexts. And the conclusion of the scenario of the general adoption of IPM is that IPM in arable field crops would not endanger food security. If you want to know more about this study and this PhD, please go and read the article that were published based on the PhD made by Martin Lechner. Thank you very much for your attention.